So guys, I'll start. I hope everyone have joined. I'll request everyone to now put themselves on mute. So this session will be about the overview of Cisco IP telephony and products of Cisco collaboration. The last Saturday I gave this training, and this is the same training we are going to repeat again. So starting will be from the traditional telephony systems, that was the plain old telephony system POTS. Uh, POTS was a kind of system where there was a telephone exchange, and it was not using the optical cables. It was the traditional telephony system that everyone is aware about, the landline system that they used in past. So telephone exchange provider provides the line that comes to the home, and that's connected using the FXO and FXS port to the landline phone, and that's how that connection works. In past, there was also some kind of scenarios where you have to call the telephone exchange, and they put you on hold, and then they connect the destination party and then join the call. This was called the trunk call concept in past. So initially, this concept was not successful for uh, multinational companies or for office scenarios. If you'll take an example of a BPO, in BPO, you cannot accept this particular scenario where every single phone have its own wire that is coming from the provider to your desk. And in BPO environment or in a contact center environment, in every floor, there are about 100, more than 100 people sitting on a single floor. Everyone have a separate desk and a separate phone. So when all these people use their desk phone, it's very hard to identify which wire is coming from which location, and it's not practically possible to manage this connection using the analog telephony. And when there is an ongoing issue in a contact center, the business is impacted immediately, and they don't have that much of time to identify which wire is coming from where and how to troubleshoot it. So this become very much hard. So it was not used in these kind of scenarios, and it's not practically possible to use plain old telephony system for corporates and BPO contact center environment. So the VoIP telephony was introduced, and in VoIP telephony, when I say there was a generation of a unified communication that came, the first product was kind of a CME, Cisco Call Manager Express, and this was a CLI based tool. Basically, it was configured on a gateway, and there is completely ePhones, ePhone DNs, and complete dial pairs that were configured over this call manager gateway, and we call it as CME. So it is basically, you can understand, in current scenarios there are SRST modes, survival remote site telephony. So the same kind of configuration currently which we use for the SRST is was implemented in the CME, and there are ePhone DNs, all of these different dial pairs that are configured, and multiple phones, but limited to a single particular site, can be configured over this CME. So it was only for a single location that we can use the CME. Then there are two kind of a difference that you guys have to understand when it comes to the unified communication. The first solution is an on-premise solution. So currently most of the companies are using on-premise solution, and second solution is off-premise solution. That is, it is hosted on, not on your data center, it is hosted on the Cisco's data center. Currently, like a scenario where you can see Teams, Cisco WebEx Teams, and most of the phones now are coming with the activation code, and these are directly registered over the cloud. So the concept of on-premise and off-premise is only for the companies who cannot, it's basically for the cost cutting purpose. And because every company cannot manage a data center, there needs to be UCS box, and a single UCS box comes about 30-35 lakhs rupees, depending upon the B6K, B7K, or what kind of a UCS box a company is using. And after that also, they have to manage their own data center, which is not cost efficient. And this is the reason Cisco have currently launched the off-premise solution, where all these machines, like if you are aware of smart licensing, smart licensing is not installed on your premise, it's an off-premise thing, but you have the complete control of smart licensing if you want to purchase license. So similar kind of scenarios people are using nowadays for off-premise solution of the CUCM. These all the applications are installed in the Cisco data center, but administration access is provided to different companies and they can utilize it. Then after CME, there was MCS, UCS box. I'm talking only about the major products that were used in past. So MCS box, you can understand a similar product like a CPU of your computer, but it has some restrictions that only a one virtual machine or maximum two virtual machines can be hosted on it, and it has hardware limitations, so it's not that strong in hardware. And if you have a cluster in a company, only CUCM have more than 8 nodes sometimes, so it's not possible to deploy every virtual machines. And if you have 8 nodes, it's not possible to separate 8 MCS box separately and configure these virtual machines on a separate MCS box. So then came into the picture was UCS box. Currently, most of the companies are using UCS boxes for all the virtualization, and VMwares are installed on these UCS box because these have more hardware capabilities and processing capabilities. So over one UCS box, you can deploy multiple virtual machines, be it the call manager cluster, Unity connection, or even the Microsoft or any product you want to install. The concept here is every time when you install any application, you need a raw hardware. Above that raw hardware, there is an hypervisor. You can understand that raw hardware is a UCS box. Hypervisor you can understand as the VMware. And over that hypervisor, there is an operating system which is installed. That operating system in our scenario, you can understand as the Linux or CentOS or Red Hat. And above that, the application is installed, which is the call manager or Unity connection or any application that we are running. So this is the basic architecture for any kind of application which is hosted over the virtual machines. First comes the raw hardware, then comes the hypervisor, then the operating system, and then the application. So all these basic components of unified communication that I have mentioned below, CUCM, Cisco Unity Connection, UCCX, and gateways, not the gateways, but now gateways are also coming as virtual cubes. If you guys are aware of, the CSR 1000V is a virtual cube that we can host on a VMware. So all these follow the same architecture. There is the hardware, over that there is a hypervisor, operating system, and then the application. So CUCM, we'll talk about the overview of CUCM, why it is used, and what is the use of CUCM. CUCM is used basically for the call processing, and it's the core for the unified communication because all the devices are registered on the CUCM, and we can manage the complete dial plan, translation pattern, routing, and all these integrations, be it with the integration of the CUCM and gateway Unity connection, all are integrated with the call manager. So CUCM can be called as the core component of the unified communication. On the CUCM, we add devices, we create the dial plan, we create the translation pattern, and also CUCM is responsible for different kind of media resources. So it's not necessary if there are 8 nodes in a cluster, only 4 nodes can be utilized for the call processing. Rest of the 4 nodes, one can be utilized as the TFTP server, second can be utilized as the to running the IPVMS services for the media resources or conference bridge, for all these kind of scenarios. I guess someone is not on mute. Can you guys put yourself on mute? I request again everyone to put themselves on mute. So rest of the people are getting a disturbance, and the audio is not clear. Yeah. So then comes the second component is Cisco Unity connection. Cisco Unity connection is basically the main function of Unity connection is to provide the voicemail service for the collaboration environment. In Cisco Unity connection, also there are call handlers which are responsible for the small call routings, like it's a small form of script. When someone calls the head desk number, he press one option to transfer the call to other, or two option, and there are multiple options which can transfer the calls to different based on the transfer rules we create in Unity connection. But the basic function of Cisco Unity connection is to record the voicemail of a person and provide him an access to access all these voicemail, and revert the user if someone drops the message for him. Then comes the third device is UCCX application. UCCX is basically used for scripting, and when I say scripting, it's the application where in contact center environment there are different teams, and all the agents are added in the UCCX. These agents are from different teams with the different skill levels. So we define that skill levels in UCCX. Suppose a person is skill 5 and he wants to be a part of the HR team, and if a call comes in, then based on his skill he becomes the part of the team, and application plays the script for him to transfer this complete call, and the call routing works in that way. So in UCCX, there the main function of UCCX is to configure like these are scripts, and based on the user inputs, it performs like several actions where the call is need to be routed, to which team this call will be go, and what are the inputs of the user. So there is an it's kind of a flow chart. When someone press one option, what is to be done next? If someone press two option, what is to be done next? And based on the user input, the script decides what actually is the outcome for this particular call and which agent will accept this call. And also UCCX is used for complete uh, finish environment, if you say, or the reports that are generated for the contact center. How many calls came in, who was on, who was logged out, who was logged in that particular of time, how many people have taken how many breaks. So these all things can be generated using the reports of UCCX. Then comes the gateway. Gateway, you can understand, is the device that every location needs a separate gateway, because in multinational companies, the site can be at different locations in different countries, or within a same country at different other cities. So gateway is responsible as the end device for that particular site to route these calls. I'll give you a basic example of when someone dials the 100 number to reach out the local police station control room. So 100 number is common for complete country. All for entire India, 100 number is a common. Everyone dials 100, and it reaches the local control room of that particular area. So how this is routed is, when you dial a 100 number from your cell phone, it reaches the nearest tower, and from the nearest tower, it sends the signal to the control room of the nearest location, and the local police gets involved. A similar example can be taken in the gateway. Like when you dial any number, how to identify which location the call is to be sent, or from which location the call is originated, is the gateway, because gateway is connected with the provider, and PSTN based on the circuit IDs that is shared in the initial part when we configure the provider and the line between provider and the gateway. So we share all these details, and that's how provider gets to know which calls should be routed to which location. Also, the second use of these gateways are to for the billing purposes. Also, these are used because if there will not be multiple gateways. Provider will not be able to understand, like someone is calling to a company, and that company has multiple locations, but in India the providers are Airtel, Idea, Geo, Reliance, and all these things. But in US there is AT&T, in Finland there is Telesoneta. So which provider will route the call to which gateway is identify when these connections are configured between the provider and between the company. So that's how provider get to know which location the call will go, and from which location, which site this call will come in, and how it will be routed. On gateway, we configure based. There are different kind of gateways. There are cube SIP gateways. There are MGCP H323 gateways, and based on the dial pair configuration, it decides how this call will be routed. Like in the next example, there is image. I'll take change the slide. So there are different deployment scenarios which we will talk in this slide. That there are single site deployment, multi-site deployment, and multi-site distributed environment. In every site, the common thing is a gateway, because every site will have its own gateway, but the CUCM cluster can be common as well as the shared part. So this is the example of single site, multi-site, and distributed call processing environment, where in single site you will see there is a PSTN, there is a single gateway, and the call manager nodes, be it the publisher, subscribers are at the same site, and users are all at the same site. So these are connected, phones are connected to switch, and switch is connected to the gateway, and the call is routed to the provider. So in single site, everything is on the same site. In multi-site WAN environment and centralized call processing, the call manager cluster is only at one location. Publishers and subscribers are all at one location. Every site have its own gateway and a connectivity to the PSTN, and the two sites are connected with the WAN traffic as well. So gateway is the common part for every location. Every site have their own remote. These are remote sites, and call manager is only at the first site, central site, where the call processing, addition of devices, deletion of devices, and configuration is managed in the central site. And remote users are logged in and signed in or configured in different sites. The third example is for the multi-site WAN with distributed call processing environment. Here there are three sites, and every site has its own call manager. It can be a same cluster as well, or it can be different clusters at a different sites. So we'll take, suppose the publisher and one subscriber is configured in the central site, another subscriber is configured in second site, and the third subscriber at the third site. All these are connected using the gateways. Gateway again is a common part in all these sites. So gateway connects using the PSTN and WAN traffic. All these sites, do of all these sites can be different, and they use this database of call because there is the connectivity between the cluster. If publisher it at one side, so every data is replicated on all these subscribers as well. So all these nodes have the information if a person dials any number, where this call needs to be routed and which site this call we routed to. In the example, you can understand, if a phone is dialing the international number, and central site is an international site for the remote site user. So when he hits the dial any number, based on the translation pattern and the route pattern, there is an end device which is always a gateway or a cube, which is associated with that route pattern, hits the gateway, and the call will be routed to the international, using the international dial pattern to the central side, and that's how the call is routed in all these kind of scenarios. If this is an internal dialing call, the call will be routed using WAN traffic. If there's the PSTN is involved, then the signaling will go through the PSTN side. The basic thing for all these things to happen and calls to be initiated and routed is for the phone to get registered. And if the phone will not get registered, you will not be able to dial anything. You will not be able to utilize all these kind of features. So the phone boot up and phone registration is must. And in this part, these all components are very necessary. The first is IP phone itself. Then there is a switch where this phone is connected. Then there is a call manager. Call manager can have its own TFTP. In some cases, there are proxy TFTPs. So both these scenarios can be covered. And there is a DHCP to provide the IP address to a phone. So phone boot up process works. Phone gets the power using three ways. Everyone would be aware of the PoE switch. Most of the company use PoE switch, then the power brick and the patterns. So the PoE switch sends the FLP signal, that is the fast link pulse, continuously when a device is connected to a PoE enabled switch. So switch sends the fast link pulse, and as every phone have different capability of consuming power, like some phones consume 14.4 volts power, other phones consumes 15.4 volts. If there is a video device, it consumes more power. So the power negotiations happen in between. When FLP is sent from the switch to the phone, it sends the maximum power that a switch can supply to a phone. Then in CDP, Cisco Discovery Protocol is the protocol through which all these switch uh, decides uh, which devices are connected. If it is a Cisco device, it will be discovered using Cisco Discovery Protocol. If it is a third-party device, then you can use LLDP protocol to discover all these devices. When CDP discovers these devices in the CDP packet, it sends the header name as TLV, type length value. In this type length value, the phone sends the power which it requires actually. So the power negotiations happen in the CDP step where the phone sends its power, and switch already have sent its power in the fast link pulse. How much power is required is shared with the switch, and the phone loads its stored image, the basic firmware that is already stored in phone. It is invoked, and it loads the stored image in the phone. CDP also delivers the VLAN information to the IP phone. VLAN is a broadcast domain. So when this VLAN is delivered to the phone, phone sends a broadcast discover request because the phone needs an IP address, and it follows a DORA process. Discover, request, offer, and acknowledge. This is the steps which phone follows. So phone will send the discover broadcast request, whichever the DHCP pool, because there can be multiple DHCP pools in a same site. DHCP pool 1 and DHCP pool 2 are similar examples. And every DHCP pool have a range of IP to offer to that particular phone. Whichever DHCP receives this request will send the response back to the phone. Phone will the phone will also request for which IP it wants, and will acknowledge in the acknowledgement step. It will acknowledge to which IP address this device will going to get registered. Once this DHCP also provides the option 150 address. So it provides the TFTP server address to these phones in the DHCP DORA process itself. Once the phone have the TFTP IP address, TFTP server is basically responsible because it's the part of the call manager, and we configure all these devices. The firmware is on the TFTP server. The configuration directory number or device information is in the TFTP server. ITL file, CTL file based on the mix mode or a non-secure cluster is on the TFTP server. So once the phone has the TCP IP address, it will request first for the CTL file, because the phone don't know if it is a secured or mixed mode cluster. It will send a get CTL request. If it's a non-secure, it will not receive a 404 not found. Then it will send a get ITL request. When phone sends get ITL request, ITL file is a signed file which contains the public and the private key for every phone to identify which cluster it belongs, because a site can have multiple clusters, and when you plug a new phone to a site, it don't know which cluster the phone will register. And this complete acceptance of this configuration file depends upon the ITL file of the cluster phone is having. So in the next slide, there is more clarity about the ITL and CTL file. So the concept is a security by default, which
Sorry,
was
can you
not.
repeat the CTL and ITL?
Mhm.
Can you please
Yeah.
repeat the CTL and ITL?
Yes. So in this example, I'll explain it, CTL and ITL file. So phone receives the ITL file, and that ITL file is a signed file which contains the public key and the private key, which is shared with the phone to decode it. So phone also requests for the scp.mac.cnf.xml file. This is the configuration file of the phone. When phone requests this configuration file is signed first, and then it is delivered to the phone. So if you see in the diagram, the first part is scp.mac.cnf.xml file. It is processed using the hash function MD5 or SHA-1 algorithm, and it provides the hash output, and that hash output is again encrypted using a private key, and this private key is basically a call manager.pum certificate that is in the call manager itself. So call manager.pum certificate sign this particular encrypted hash key, and this becomes scp.mac.cnf.xml.sdn. .sdn part is added in this when this is particularly processed using security by default. So the second step is for phone to accept it based on the ITL file of its particular customer, because ITL have the public key to decode it. So this phone receives the scp.mac.cnf.xml.sdn file. This is separated again in two parts. One part is dot sapcnf.xml, and the second part is the signature part, SDN part. So SDN part goes from the decryption, and as the phone already have the public key to decrypt it, it performs the decryption and decrypt the hash value which was encrypted in previous step. So it decrypts the signed file and generates the hash key, hash value. In the second part, again, there is an encryption going on, which XML file is going through the hash function MD5 or SHA-1. It also encodes it again to a hash output. If these two hash output, one the SDN file decryption and the again SDN sapmac.xml file encryption, if these hash output matches, then the phone only accepts this particular configuration file. And because you might have seen the phone is not getting the configuration file, or it in some scenario it's not accepting the configuration file, we generally delete the ITL file of the phone. And this is the only reason, because the phone is not able to decode the SDN part of this particular configuration file, and it does not accept it, and phone is not registered in these scenarios. So security by default was introduced after 8.6 call manager and continuously in use after that. And this separates which phone will register to which cluster of the call manager in the environment. So once the phone is registered, then the protocol responsible for the calls to connect are SIP and SCCP protocols. This the These are the signalings which are transmitted between the phone call manager and the other phone. And once the call is established, the RTP flows in between the end device. So user A and user B in this scenario are connected using the RTP, and media flows directly between the end device. SIP is the session initiation protocol, and SCCP is the skinny client control protocol, which have different signals. SIP have basically invite, 100 trying, 180 ringing, 200 okay, and these kind of message. In second slide, we have this. So the basic SIP signaling, when the phone is registered and someone dials the number, phone sends the invite to the call
Momo,
manager. When the SIP invite have
Can you
the
please
two
ask everyone to mute?
from,
Because there is a lot of noises
yeah,
coming.
because there are a lot of people in this. I'm not sure who is unmute. I'll again request everyone to unmute themselves. I guess State is not on mute.
You can mute
And
on yourself. If you're a host, you can mute all the persons.
someone else is hosting it. Yeah. So phone sends the invite. This invite message have the headers, which is the two, which is the itself calling party number, call party number, and the address of the call. It sends the invite to the CUCM. And again, there is a concept of early offer and delayed offer, which comes into the picture when the call manager is involved. So basically, early offer and call manager itself is a delayed offer. By default, it follows the delayed offer process. It does not send its capability first to the end party. It waits for the other party to send its capability and the SDP. SDP contains the codec information and all the information about the how, on which codec this call will get negotiated and how the call will get connected. If the media resources are required or transcoders are required, depends upon the codec negotiation part. So in invite, the phone contains to, from, and other information about the its phone. Then it sends to the CUCM. CUCM forwards this to the SBC. In this scenario, it can be a gateway, any gateway, MGCP gateway, ST23 gateway, or the SIP gateway. And then the SIP gateway is connected with the provider, PSTN. So here you see the signaling is initiated from the IP phone. It sends the invite to CUCM. CUCM sends the same invite to the queue, and it sends the invite to the PSTN provider and receives. There are more signals, but these are not mentioned in this particular slide. There is 100 trying first, then there is 180 ringing, then there is 200 okay. Once the 200 okay is sent and accepted by the phone one, then only the media
खोबरं
is
घातलंय.
established. Acknowledgement and the session is established in between. And when someone's uh, like hang up the call, the bye message is sent. Let me ask someone to mute because there is a lot of background noise. See.
Galaxy, the user with Galaxy is in unmute.
I think the user with Galaxy M20 will be muted because the we can notice the audio from Galaxy M20.
So now I have muted everyone, so I guess there will not be a lot of disturbance now. So in this particular scenario, I guess you guys would be understanding the basic call flow, how the call works. When someone dials, the call is invite is sent to the call manager. It forwards the invite to the SBC gateway or any type of gateway, and then it forwards the call to the PSTN, and then receives the 100 trying message back, then 180 ringing, 200 okay, and 200 okay, the media is established, and when someone hang up the call, then the buy message is passed and the call gets disconnected. So early offer and delayed offer is a main concept which needs to be understand in this particular scenario because the codec and on which bit rate this call will get established depends upon the SDP part. A phone phone accepts all these kind of codecs, be it G711, G729, and all these codecs have different bit rate. G711 talks on 64 kbps, G729 talks on 8 kbps. So when a site is deployed, all these things are considered, and which site, which location have how much bandwidth to like establish multiple sessions at the same time depends on the deployment site when we deploy a particular environment. So when these sites are deployed and the phones are registered, the basic components for a phone to make a call or receive a call are these directory number, dialing patterns. Dialing patterns can be translation pattern and route patterns. Translation patterns are involved for the internal translation of that particular site, and route patterns are involved when the call is sending, going out using the gateway or going to the PSTN provider. Then there is a partition and CSS, calling search space. So concept here is to basically, it is called as a class of restriction concept, where we want people to restrict and allow based on the administrator of that particular site, that who will be able to dial which number, who will be able to dial internal numbers, and who can reach international calls. So in an example where a director of a company, you can take an example, a director of a company wants a feature where he can reach any employee of the company, but any employee can directly not reach the director of the company. He can only reach the personal assistant, and that assistant can reach the director of the company. So he will restrict this particular scenario and achieve this scenario based on the CSS and the partition options. So in first, there are 4 scenarios here. The first CSS have internal calls CSS that can only reach the internal calls, all the phones within the organization. Second phone has CSS local. It can reach internal calls as well as the local calls. Third CSS is the long distance CSS, where a person can reach all these local like internal calls, local calls, and the long distance PSTN. And the third phone contains the CSS named as CSS international. This person can reach any call, any location, be it the internal phones, local, long distance, and the international calls. So this completely depends upon the scenario of a lock and key. CSS is a list of keys, and partitions are kind of lock. So this CSS local has 2 keys in within it. That one is PT internal and PT local. To access the lock PT internal, when this PT internal, CSS should have PT internal in within it to reach 1000 and 1000 number. To reach 2-X second pattern of the local PT local, CSS should have the PT local within it to reach this particular pattern, PT local pattern. And the third pattern for PT long distance will not be reachable from this phone, as the CSS do not have PT long distance partition. So CSS contains basically the list of keys, and partitions are all locks, which can be configured to restrict someone to reach any number. And last, we'll talk about the example, because everyone is nowadays connected using we are connected using the VPNs and using Jabber phones. So there is a last slide. I'm trying to see if it is there in this. That is the Expressway VPN-less connection scenario. Yeah, this one. So when we are connected using the VPN, if we are connected using VPN, that means we are on the same network of the company, and additional things are not need to be provided. It basically works in the same way how you are within your company. When you are connected using VPN, you get the IP address of your network, and the calls are established and devices are registered based on that. But in nowadays, people are using MRAs, a Jabber VPN-less connection. And to deploy this scenario, we need expressways to set up this particular environment. And this talks on internet. So there are two main components for such Jabber VPN-less connection scenarios. One is the Expressway C. This is the control part which controls everything. And second is the Expressway E. This is the edge part. So the control part is deployed in the voice VLAN of the company, and the Expressway E is deployed in the DMZ zone of the company. And there are two different firewalls that you can see in this particular diagram. And Jabber is connected over the internet. So in this scenario, a person using Jabber will not require a VPN connection to connect. It only requires a DNS and the user ID and the password to log in into Jabber, and he will be able to use this. So Expressway E has the public IP address. It has only a single IP address. So single leg deployment example this is. So it has the public IP address which is mapped using the A records and SRV records, and we provide our domain name DNS for this particular Expressway. So public IP again is an static IP address, but in the main problem comes when all the Jabber are registered to the call manager, and call manager sees that all the Jabber are registered with the single IP address. So when the media is established, there are most of the cases where our chances of one-way audio, there is no audio because the IP is same for all these Jabber that are connected. And to avoid this, we use netting, and we do this netting in this particular after the in the firewall, which is just after the Expressway E. So by doing the netting, we configure the net loop back in the firewall. So it separates the single IP address with the multiple IP address. So when the media is established, the port and IP should be different for the calls to connect, and the audio node will be collapsing between these different devices, and there will be no one-way audio or a no-way audio issues in this scenario. So this was requested by one of the guys, so we did the deployment for him. And in deployment scenarios, this is the Cisco recommended scenario, but there are more ways to deploy and achieve the Jabber VPN less connection. Yeah. So if you guys have any questions on the overview of the call manager, we can talk that. And if you want a presentation on a specific topic, then we can also, you guys can just text me in the chat your question or in the WhatsApp group, and I'll be there to answer all kinds of your queries. Also, yesterday someone called me and he was talking about establishing his own virtual lab. So if you guys have hardware, then only it is possible. Without hardware, it is not possible. People think that they can use cloud to set up this particular lab, but the license, any platform which have the capability to configure a virtual machine can configure this particular lab. And as I said, the architecture is raw hardware is always required. Over the raw hardware, there is the hypervisor, that is the VMware, and over the hypervisor and then operating system. So raw hardware will always be required to configure any lab environment in for your personal use. And if you want to use it and you have the sufficient hardware capability, you can deploy using the OVA template and the bootable bootable that are freely available on the Cisco sites. And that's not the issue. If anyone have such kind of questions, you guys can reach me on the WhatsApp group that we have created or directly from
Hello, hi Tanay. I have one query.
yeah.
So the CTL ITL file concept comes in case where we have SIP phones, or it will come in SCCP scenario also.
It will come in SCCP as well, because the CTL, the configuration file is always common. It's not a
Okay.
SIP file or a SCCP file. The phone always wants a configuration file, and whenever it wants a configuration file, the configuration file is always a signed file, and this configuration is filed using the call manager.term certificate. you guys might have downloaded also these files, because you can download it using the TFTP 6970 port, and there is a complete URL to download a configuration file, and that file is cnfxml.sgn file. So the sgn part is the encryption that is assigned using the call manager certificate. Yeah. So it will always be either
Okay,
a SIP phone
so
or
I
the
was wrong.
STTP phone.
So I have searched somewhere on Google,
Yeah, yeah.
and there was mentioned like
Mm-hmm.
the CTL files come only in SIP scenario. Okay, fine. So, and one
No,
more
no,
query.
no. Okay.
Okay, so I have one more
Mm-hmm.
query. We are planning to have our one of our new branch in India. So my query is
Mm-hmm.
like our management is asking what will be the benefits or demerits if we will have a local queue, what will be the merits, and if we don't have the local queue and we are just taking the services from our centralized queue that is in US, so what will be the demerits? So I just want to ask like what will be the advantage
So
and disadvantage?
yeah, it completely depends upon the call processing, how many calls will be coming to this particular site, because every cube have a certain limitation to handle the calls, number of calls that will be coming in based on the licenses, and there are media resources that are configured. Suppose there is a transcoder, there are MTPs, media termination points, that are configured on these gateways, and these gateways are cubes, routers. So it depends upon how, what is the call processing and where is your provider. Because when you will be making a call and your
Mm-hmm.
cube is in US environment,
Mm-hmm.
so or if someone is calling from India, it will be a long distance call charge for him. So it depends upon the charge, how this toll is charged to the user, because it is not routed using the, if it is not routed using the WAN traffic, then there are chances the cost will be high for these calls. If the WAN traffic is there, then it's absolutely fine. If there is no
Okay,
WAN
and
traffic between these sites, yeah.
make our emergency calls, let's say 100, 101, 102 via that US based queue, or it will not be possible?
So it depends upon if you guys are using the uh, am I, are you using the, talking about the 911 or 100?
I am talking
Because
about
for
mobile
911,
because
there,
911 is already working. That is for US. But let's say if we are
yeah.
planning to
So
open India side,
so
India
it
location.
it it won't work. It won't work without the local gateway, because as I said, it will be hard for them to identify the location of the user. So in 911 there is emergency responder, CER, and this CER we can configure the location. We shared every detail with the provider, but when you talk about the 100 dialing, it detects based on the local gateway. SLRG is the concept, standard local route group we create, and based on that, the local route group, local uh,
Mhm.
gateway, the site is identified.
Okay,
Yeah.
fine. Thank you.
Yeah, I have query for the expressway regarding expressway age. It's a dual net.
Mm-hmm. Mm-hmm.
You explained about the single IP address, right? The single LAN. What about for
Mm-hmm.
the dual LAN
Mm-hmm.
using the expressway age
Yeah,
dual?
this was only the one scenario, that is a Cisco recommended scenario. So I have not taken it much into deeper side, because this was only an overview of the Cisco collaboration. But someone requested me about the Jabber VPN-less connection, so I considered the Cisco recommended scenario. But there are total three scenarios that can be covered for a deployment. If you have these queries, then you can ping me on the WhatsApp or in that particular group. I can explain you a detail. There are files, there are documents which contains all these three scenarios to deploy a Jabber VPN-less connection. Yeah.
Okay, thank you.
Yeah,
And can you
Tanay,
just explain?
if a DHCP server is down or TFTP server is down, in that case, how the IP phone takes an IP address or how it gets registered?
So if the DHCP server is down, there, in these scenarios, there are redundancy that needs to be created. And if the DHCP server is completely down, and there is only a single phone, we can provide the static IP address, and that we have to give the manually. Or if we have some other DHCP, we can give the IP of that particular DHCP server using IP helper address, and that phones will start getting the IP from that particular third DHCP server. But for a phone to get an IP address, a DHCP will be required. And if not, for single phone or a few phones, we can give the static IP manually on the phone part. But for an enterprise, a DHCP is required.
What if TFTP server is goes down?
Yeah, if TFTP server is down, then again, phones will not be able to get the configuration file. If phone have its own configuration file, till that time it's fine. And until and unless a new change or a reset action is not performed on the phone, so it has the configuration file, it will be registered if the call manager is up. Also, it depends if it's a local TFTP server or a proxy TFTP server from the phone, from where these phones are getting the configuration file, because there is also a dependency. When you open the IP address of the phone in GUI page, there is TFTP server 1, TFTP server 2, and TFTP server 3. The three TFTP server are used for the dependency purpose, and it's recommended the TFTP server has to be up for the phone to get successfully registered, because if it somehow gets unregistered, it will not be able to register back if the TFTP server is down. Yeah.
Can you give some brief description on early offer and delay offer?
Okay. So the early offer and delay offer is the scenario only for sharing its capabilities. When phone shares, when you dial a number, it sends the invite, and call manager by default follows the delayed offer scenarios. That means phone sends the codec and capabilities to the call manager, but call manager does not forward this capability to the destination party. It holds these capabilities, that is the SDP. Invite is sent in two forms, including SDP and without SDP. So in the delayed offer scenario, invite is sent from the call manager without SDP. It does not send this capability to the destination. Destination sends again the invite to the call manager with the SDP, and it has all the particular codec information of the destination device. And then once the destination codec and SDP is received to the call manager, it sends its SDP in the 200 OK message. When the SDP is sent in the 200 OK message, there is a negotiation between the codec. If a device is only supporting G711 codec and the destination device is supporting only G729 codec, then there will be an issue for the call to get connected. The media will not connect because of the difference in, there is a mismatch in the codec, and the media will not be connected. So in these scenarios, a transcoder is required to convert higher bitrate to lower bitrate. As G729 codec talks on 64 kbps, and that can be compressed and converted as a 8 kbps, and the destination party accepts G729, which talks on 8 kbps. So higher bitrate is converted to the lower bitrate using these transcoders, and the media is connected. But if there is no transcoder in between, so the call will not get established. And the early offer and delayed offer is basically only used for the SDP part, how the call will accept the capabilities of the destination party and send its capability. Yeah.
So in case of early offer, will be a prac message every time?
No, that is the early media. So there are two things: early offer, delayed offer, and early media. Early media, when it comes, then only there is the 183 session progress message sent, and we receive the prac message. So these two are not same kind of scenario. Early offer, delayed offer is a different scenario, and
Okay,
early media
so
is a
in
different
case
scenario.
of early,
Yeah.
I'm just correcting my question. In case of early media, will there be
Mm-hmm.
prac every time
Yeah, yeah,
when we are?
yeah. So
Okay.
it depends upon the provider. 183 session message is sent, and a rel 1xx message, whenever there will be a rel 1xx message, it will
Mhm.
receive a prac message as well. The prac is nothing but the pre-acknowledgement. Before this call
Yes.
is getting connected, there is a pre-acknowledgement for an early media to transmit.
So in case of early media, so will there be
Mm-hmm.
180 session or 183 session?
183 session progress for early media.
Okay, so there will be no scenario in early media where we can see 180 ringing, and it's
The
early
main
media.
motive of early, yeah, the main motive of early media is before the call gets connected,
Correct. Yeah.
the media should flow in between. Like when you dial a
Yes.
customer care number, you hear
Mhm.
an advertise, and company don't want itself to get charged for that particular advertisement. When only the call is connected, billing start after that. So this concept was like came in picture only to avoid the charges before the call is getting established. So media always gets established after 200 OK message, and before, if there is the advertisement part coming in, that
Mhm.
advertisement media comes in with 183 message, 183 session.
Okay.
180 ringing is the ringback tone that you hear, and 183 is the advertisement, the early media that you hear.
Session progress.
Yeah,
Okay. Thank you.
I guess we are good. So if you guys have any questions, you can just ping me on the WhatsApp group, or you can contact me on the LinkedIn. I'm always active there and can answer all your queries. And if you guys have any kind of issues with any scenarios within your company, then also you can reach me
I
anytime.
have a question here.
Thanks guys for your support. Yeah,
So I just wanted to
yeah,
know,
tell me.
like, can we deploy MRA for Jabber in the lab environment, though we don't have any public signed certificate?
No, so it is basically the public IP will be required for that, and it depends if you have the Expressway E and Expressway C both, because Expressway E always requires a public IP address, and MRA is used for the remote VPN-less connections only. So it will be required.
Okay, so we
Yeah,
cannot replicate that setup in the lab environment.
in the lab environment.
Okay.
Yeah, I have the same question like for the SIP early media message. Still not clear.
Mm-hmm,
Like if because what we did if sometimes the call is not able to mature, we do the SIP early
mm-hmm,
media and then call get mature. So is this kind of like
mm-hmm.
the SDP is not negotiate prior to the call? If we do that SIP early media, the call will get mature so that it helps if we face any
Yeah,
issues like.
yes, yes. So it totally depends upon the provider, which message the provider is accepting, or so if their provider don't want to send the ringback tone, and he wants to send early media or an advertisement in that, so in that particular scenario there will be 183 message, and it also depends upon if the call manager chip profile rel1 xx message is checked over there, then it will require the 183 message even if there is not an early media scenario. So it totally depends upon the configuration part.
Okay, okay. And
Yeah.
what is the role of MTP basically? Because if we create the SIP trunk kind of to the third
Mm-hmm.
party devices, so do we need to set the
Yeah.
MTP kind of, or it will consume the resources
Yeah.
unnecessary?
Yeah. So MTP basically is required for the main concept is because of the DTMF to accept the DTMF digits when a call is connected, and you press one option, two option to reach these digits to the UCCX or Unity connection. MTP is required only, and that also depends what configuration you have done on the SIP profile. So there is out of band in-band, and RFC2833. These three are the DTMF type that are involved in the Cisco collaboration. So if the other party requires, there is a DTMF to be required, and there is a DTMF mismatch. Suppose you support in-band and other party supports out-of-band DTMF digits. So MTP will be required in that particular scenario. But Cisco recommends not to use many resources when for a single call. So we don't check all these time MTP required check. There is an option in the SIP trunk. When you check for all the calls, MTP will get invoked, and there will be call failures if multiple calls are using these MTP at the same time, because resources are limited and calls are many.
Okay, so the same scenario I'm just discussing, like there are two different cluster, two different sites. If you want to communicate them in means internal dialing, then we allow the IP subnets, right? Voice subnets we allow on both the firewalls, both the cluster. Then only it will work. Can we do MTP?
Yeah.
Is there kind of if we allow MTP for, if suppose only 10 calls, it will be, I know that in between cluster, two different networks, there will be only 10 calls maximum. So can we do it with the MTP kind of, or we need to allow, or we had to allow the IP subnets, full voice IP subnets, because
No,
that is
no.
actually.
So for MTP, if it's between two clusters, uh, MTP, you can, like, you have the information about the other cluster and your cluster, so you can only make it common. Like, there are three options whenever you will see in the SIP trunk for the MTP part, the DTMF digit, as I said, out of band, in band, and RFC2833. So if it's common at both the sides, then MTP is not even required. And if this configuration is different on both the sides, then only MTP will be required. And it's not a recommended configuration to invoke MTP for all these calls.
Okay, but that is for sure, like voice subnets, both sides we need to allow, because RTP streams between phones only, not the call manager. So if we will not allow the IP subnets on both the firewalls, call will not get mature, right?
Yes.
Okay.
So for more questions, you guys can just send me on the WhatsApp, and anytime I'll be there to help you guys. And have a great day. Yeah.
Thank you so much. Thank you so much. Yeah.
Thank you so much.
No problem. No problem.
Yeah,
Have
it's
a great
very
day,
good
guys.
session. Yeah.
Yeah.
Hello. Hello. Hello.